Good morning, students. Myself Dr. Shantini Bhattacharya, Assistant Professor ECE Department, SRM Institute of Science and Technology, Gattankulathu, Chennai. Today I am going to start the new topic of digital logic design, up and down counter. Okay. So here I will cover both synchronous up down counter and also asynchronous up down counter. So I am starting with the asynchronous up down counter. So first of all of you know, I hope all of you know that what is the actually meaning of the asynchronous counter. So I just repeat once again that asynchronous means only clock pulse is directly connected to the first flip-flop. Okay, that means flip-flop number A, and output of the first flip-flop is worked as a clock pulse of the second flip-flop. Output of the second flip-flop is worked as a actually clock pulse of the third flip-flop, and also this is as a 4-bit up down counter. So this is the general output of the third flip-flop is actually connected as a clock pulse of the fourth flip-flop. It is a 4-bit. So first of all, just look at this design here. As it is a 4-bit asynchronous up down counter, so we need 4 flip-flops. Okay, so flip-flop number A, B, C, D. So input J and K of all flip-flops are connected together and it is connected to VCC. Okay, that means if I connect to 1, VCC means 1 or 5 volt, so it is continuously toggle with the clock pulse, applying clock pulse. Okay, now here is the one important thing in this design. You can see that there is a 2 lines are there, count up and count down line. Okay, so that means count up means, in that case count up means here the countdown starts from 0 0 0 0 to 1 1 1 1, and count down means its counting starts from 1 1 1 1 to 0 0 0, then again it will start 1 1 1 1. That means slowly it will decrease the count and it will come to 0 0 0 position, and in the count up slowly it increase the count and it will finally reach 15, and then again starts from 0 0 0 0. So this is the basic difference of count up and count down. Okay, so how it will do. Okay, so in the case of first I will explain how I will count the up. Okay, so in that case you can see there is a count up line and count down line. So there are basically AND gate 1 3 5. One input is connected to count up line and other input connected to QA. Okay, QA, QB and QC. Okay, and in the case of count down line, here AND gate number 2 4 6, one input is connected to count down line and another input is connected to the complement output of the, that means QA bar, QB bar and QC bar. So first of all I'll explain how I will count the count up. Okay, so in that case we will actually keep count down line is 0, and all of you know that if this count down line is 0, that means AND gate 1, that means AND gate number 2 4 and 6, one input is 0, and all of you know this is the basic AND gate principle. That means if one input of the AND gate is 0, that means output will be 0. That means in the case of count up, no output of the complement, no complemented output, that means QA bar, QB bar, QC bar will go through the through this 2 4 6 NAND gate, and it will not reach to this OR gate. Okay, so in the case of count up line, because we are actually keep count down line is 0. 0 means AND gate number 2 4 and 6 are disabled. Okay, now in the case of count up, that means now we keep count up line in this count up mode. Count up line we will keep 1, that means AND gate number 1 3 and 5 are enabled. So when we apply clock pulse in the first flip-flop, then what will happen? Then output of the QA is transferred to through this AND gate number 1, and through the OR gate it will reach to the clock pulse as a clock pulse of the flip-flop B. Okay, then similarly in the next clock, this when it will reach, that means QA will reach to flip-flop B, then it will also start working, and then only the count up line, that means 3 also, 3 gate number 3 also enable. That means output QB only pass through this AND gate, and output QB bar will not pass, because that means 4 AND gate number 4 is at that position disabled because countdown line is 0. So only QB is transferred through the OR gate, and it will act as a clock pulse of the flip-flop C. Similarly, here also gate number 5 is enabled, gate number 6 is disabled, and that means output of QC is transferred through this OR gate, and it behaves like a clock pulse of the D flip-flop. In this way, count up mode basically works. Now I am discussing countdown, okay, mode. Countdown mode. In the case of countdown mode, what will happen? In the case of countdown mode, we will keep count up line equals to 0. Okay, same thing, just opposite. Okay, in that position, count up line equals to 0 and count down line is equals to 1. So as we keep count up line equals to 0, that means this flip-flop number 1, this AND gate number 1, 3 and 5 will be as a disabled, okay, condition, and count down line as it is 1, so 2, 4 and 6 AND gates are enabled. So in the case of count down, no output of QA, QB and QC will transfer through these AND gates, okay, because AND gate number 1, 3 and 5 are disabled because count up line is at that position 0. That means if one input of any AND gate is 0, then it will output will be 0. Then that means 1, 3 and 5 it will only give 0 value. So if OR gate 1 input is 0 and another, it only depends on the another input. So at that position, when count down mode we are discussing, count down basically line we will keep 1, and for this purpose, so QA bar, QB bar and QC bar pass through the AND gates number 2, 4 and 6, and also here actually clock is given in the first flip-flop, and then QA bar is transferred through the NAND gate number 2 and also this OR gate, and it acts like a clock pulse of the flip-flop number B, in same as QB bar pass through this AND gate 4 and also this OR gate, and it acts like a clock pulse of the flip-flop number C. Okay, then similarly last case. Okay, so in this way asynchronous up down counter basically works. Now I am discussing about the synchronous up down counter. In the case of synchronous, meaning is we are actually giving clock pulse simultaneously at a same time all flip-flops. So same thing actually I have given, that means this is a clock pulse where all flip-flops I have given the same clock pulse. Okay, and the design is almost similar to the asynchronous up down counter, but little bit difference is also there. So here actually 3-bit basically counter we have taken for this purpose. It is 0 0 0 to 1 1 1. It will count and for count up mode, and again it will start from 0 0 0, and count down mode similarly it starts from 1 1 1 and it will continue to 0 0 0. Again it will start from 1 1 1. So in the case of here count up mode, first of all we have to keep, that means count, same principle, count down line we have to keep 0 when count up mode will work. Okay, count down line is 0 means AND gate number 2 and 4 will be disabled, so no output, that means QA bar QB bar will not pass through AND gate number 2 and 4. Okay, so or at that moment only when count up mode, only AND gate 1 and 3 will in the working condition. Okay, so in the first clock pulse, output of the QA pass through the AND gate 1 and then it passes through the OR gate and then it acts as a input of the J and K of the B flip flop. Okay, so this is actually the synchronous counter design also, same as if you don't know the synchronous counter design, so you just go through my synchronous counter, asynchronous counter video, basically. Here how to design synchronous counter, asynchronous counter, everything is actually discussed. So based on this principle here also same, that means QA, that means output of first flip flop is it is basically directly connected, passes through the OR gate and directly connected to the input of the second flip flop. Then in the case of third flip flop, for count up line 4, this AND gate is disabled, so no output will go from this QB bar. So only here what will happen, QB, actually the output, that original QB will come here, pass through the gate or AND gate 3, and also another input is connected to this AND gate. Okay, that is AND gate output 1. Okay, that means this AND gate output, AND gate number 1 output is actually the another input of the AND gate number 3, and QB is the another input of the AND gate number 3. Both this combination is passes through, that means it is output will be AND gate output 3 is QA and QB. So QA and QB is passes through the OR gate and it will acts as the input of the JK flip flop number C. Okay. Now I am coming to the count down position, same as count up line will be at that position 0 and count down will be 1. As count up line is 0, that means AND gate number 1 and AND gate number 3 will be disabled. No output will pass through AND gate number 1 and AND gate number 3. So upper portion is totally we will not actually consider. Okay, so in the case of count down line, it is this line is actually 1. So as in the AND gate 1 input is 1, it actually AND gate output depends on the other other input. So here QA bar is passing through this AND gate number 2 and then it passing through the OR gate, and this QA bar is actually the input of the J and K of the flip flop B. Okay, then next part, that is here all clock pulse is actually simultaneously given. In that next condition, what will happen here, second flip flop also AND gate 3 is disabled, AND gate 4 is enabled. Here actually QB bar and also this QA bar, that means output of the AND gate 2 is passes through this line, and this is AND gate for 2 input is QA bar and QB bar. So output will be QA bar dot QB bar. It passes through this OR gate and this is, it acts as a input of the J and K of the flip flop C. In this way, this is actually the basic construction of the synchronous up down counter. So in this way, count up and count down of synchronous up down counter basically works. So thank you so much. Keep watching my videos, and if you have any doubt, then give me these doubt in the comment section. I will try my best to solve your problems. Thank you so much.